Hello. Hello, good afternoon, everyone. I hope you're doing great. So, welcome to this webinar. I'm going to start with introducing myself. As you know, I'm Sahar Ebadinezhad, and my research interest actually is a wireless communication system, millimeter wave communication, vehicular communication, which actually today I want to talk about this area of research, body-centric communication, and also cloud computing. So these are my research interests that I'm actually great about that to do this kind of researches. Now, actually, let us start to see what we're gonna have today and what I want to talk about. At the first, I would like to give you an overview of what I want to talk about, and then I will actually explain in detail about the MANETs, VANETs, and after that IOVs in terms of their architecture, the existence challenge, and the application of actually each of these above mentioned technology that I said. Also, at the end, I will talk about some previous researches that are done in this kind of areas, in this kind of fields. So let's now look at the abstract. Hopefully everyone can see my screen. Okay. So due to actually fast development in technology, the mobile network has been rapidly changed, especially mobile ad hoc and vehicular ad hoc network, and also Internet of Vehicle, that we say to that MANET, VANET, and IOV. Also, due to nature of the field, the mobile sensor network replaced the fixed sensor network. So in this field, actually the topology dynamically changes time by time due to a speed and congested environment. So for this reason, actually routing is a crucial and challenging issue. So for routing, a variety of a new routing protocol have been developed. In mobile ad hoc network, which is MANET, in VANET ad hoc network, which is VANET, the routing protocols are actually divided into different categories, such as topology-based, position-based, and network-based. Moreover, regarding the growth of innovation and generation intelligence transportation system, an essential role is actually anticipated to be played by Internet of Vehicle. So as many as 75% of a car worldwide will be connected by 2021 altogether. So we get the advantage of using the IoV. And the growth in regard to Internet of Vehicle will be bring in approximately kind of 2.94 billion US dollar in the revenue by 2021. So for IoV actually to see its full potential, there are many challenges and math that it needs to be addressed here, including real-time vehicle data, or for example, enhancing the rate of on-time delivery, reducing fuel costs, or for example, manpower, traffic management, or an accident tackling. That are some of the important applications that need to actually be addressed here. So the ultimate goal is to actually achieve more efficient, green, and also safe mode of transportation. And in the present, in this actually webinar, I first want to introduce the concept of MANET, then VANET, and after that Internet of Vehicle, IoV, and also their architecture. So approaching toward the second part of the webinar, definitely I suggest some various solution and some issues or challenges that exist in these technologies. For a safety various challenge and also in the IoV field as well. So throughout the end, definitely I will discuss about the issue that arise in the IOV, in the IOV application, and also in the future scope, the research, actually the open research area that many researchers can start doing their research on that still. Okay, so change it. Okay, let's move to the introduction. Let's talk about the Internet of Things at the first, because when I said IoV is a sub-branch of IoT. So let's first of all start with the IoT. IoT actually is integrating of a smartness into the existing area. For instance, a smart health, a smart home, a smart energy, or even a smart industry and a smart transportation, as you see in this figure here. So Internet of Vehicle, or IoV, actually is one of the revolution mobilized by IoT. So IoV is actually evolving from a vehicular ad hoc network. It came from that is kind of new version of the VANET, to achieve the vision of from a smartphone to a smart car. So all over the world, actually, a lot of deaths are actually recorded each year due to car accident and lack drivers' attention to the road hazard. So with the actually sharp growth of number of vehicles on the road in the recent year, led to increasing the interest actually toward employment safety application. So this kind of application, it needs to request the broadcast and process important information and exchange it between the vehicles in the proper time. Therefore, the exchange data method are the actually interest of most of the researchers, which are working in the area of the development in order to reduce the number of the accidents through warning drivers about the risk before they actually face it. So intelligent transportation system, or ITS, actually make different transportation system more intelligent, safety, and utility to the people. So increased interest in the development of ITS application to can improve the road safety and fully actually dominates the vehicle, or as we say, vehicle automation, by actually providing timely and accurate data to the vehicular driver. So in another meaning, the comfortable safety driving environment, definitely it needs to enhance the routing protocols in the vehicle environment to actually achieve the purpose of driver assistance system. So now, as I promised, I want to talk about a mobile ad hoc network at first, and then we go more forward, or as we said, MANETs. So actually fourth generation, or as we said, all we know that as a 4G technology, 4G wireless system, it's actually assume ubiquitous computing and universal access for a mobile user that actually wish to connect to the internet through the heterogeneous technology. For instance, cellular network, wireless LANs, like we say to that IEEE 802.11n, or even 0.15, and also 0.16 of that. And 3G with the overlapping coverage area and also different cell size that they have. So The goal of the 4G wireless communication is to actually allow user to can communicate reliably and cost effectively via any media, and also at any time, anywhere as well. So 4G systems will actually integrate existing and the new network seamlessly, and allowing actually mobile user to can run globally with no limits to actually underlying access technology. One of the network types actually included in a 4G system is the mobile ad hoc network, or MANET. So generally, MANET is an autonomous collection of mobile user that actually moves arbitrary, and it can communicate over multiple hub relays. So the topology of a network may actually change unpredictably and dynamically. So there is no pre-established infrastructure or even pre-established backbone in the MANETs. So the MANETs are generally actually envisioned to operate as a standalone network, which means that the traffic will be restricted within a MANET. So all members in the MANET equally they can participate in the routing information distribution and also maintenance of that by running the same routing protocol. So efficient ad hoc routing protocol here must be adaptive to topological change, and it should be adaptive to the traffic demands. Also, MANETs can be deployed for temporary communication, such as conferences, emergency rescue, or disaster relief, and even for a military mission, it can be used. So, the actual integration of MANETs into 4G system will help to increase the networking flexibility and also increasing the coverage of existing infrastructure network. When we talk about infrastructure network, like for example, wireless LAN or hotspot or 3G network, 4G network that we have, as you see in this figure. So, for instance, a mobile user outside the coverage of wireless LAN cell, it can still communicate with the access point or AP by the release of actually multi-hop ad hoc that reside in the cell coverage. Moreover, a mobile user in the MANET, it can access the internet via other user node connected to the internet as well. These user nodes with actually connectivity to the wider internet will effectively become gateway between the ad hoc network domain and the actually wider internet. So as a benefit, the MANETs, it can integrate 4G system and become convergence platform with a widespread coverage and also high heterogeneity. Now let's look at the challenge of the MANETs. So, however, when we considering MANETs with the internet, the routing interoperability, it becomes a crucial challenge here. So ad hoc routing protocols are originally designed for a standalone MANET, where no actually intervention of any centralized router exists. So in contrast to the internet protocol, or all of you know, we say to that IP, So in contrast to the IP, under pure ad hoc routing protocol, every node must perform as a router, and they should participate in a road discovery and road maintenance also for the other node. So the ad hoc node, they cannot obtain the routing information beyond the scope of the MANET. So when we actually consider ad hoc routing with the rulings of IP-based networking and ad hoc routing protocols, it's not capable of handling the communication across the boundary between the MANET and also internet. Therefore, the interoperability, or we say to that interface between an IP routing and ad hoc routing, it requires some attention here. Other challenges also emerge when we consider IP mobility issue in the internet integrated method. So in 4G system, mobile devices that actually require to connect with the internet are allowed to maintain their connectivity globally when they move from one network to another without actually interrupting the ongoing communication. And 4G system actually rely on the IP networking layer to can provide mobility service in an application transparent manner across the heterogeneous access technology, which actually involves mobile IP. Therefore, as a actually substantial component of a 4G system, the MANET connecting to the internet must actually support IP mobility as well. So mobile nodes may dynamically enter or they can leave the MANET while still maintaining their communication. While the mobile IP support was designed for a system where the actually mobile host communicates with the IP mobility agents. And these agents, it can be like routers and that's supporting the mobile IP functionality over a single hub, or the communication between the mobile host and the internet gateway in MANET also is carried out over multiple hop paths. So this actually leads to challenges such as mobile IP signaling. As an example, I can mention to gateway discovering and registering over multi-hop path in MANETs. Okay, now let's look at the actual vehicular ad hoc network or VANET and see which kind of architectures exist in VANET and also which kind of challenge we have here. VANET actually is the abbreviation of vehicular ad hoc network, as I mentioned earlier, and it's a specific branch of mobile ad hoc network or MANET. So MANET has lots of attributes that it make it close to MANET, such as finance bandwidth, self-arrangement, self-administration, and unstable network topology. So these attributes, they are kind of similar between the MANET and VANET. However, some unique characteristics are exactly specific for VANET, such as very high node mobility, a lot of actual communication environments, a strict delay, constraints, and frequent network disconnection. Also, VANET architecture, it divides into three types of the network. You see here in this picture that I mentioned, visualize actually. So we have vehicle to vehicle communication, or we say always that V2V communication. And it's actually network in which that node communicate with each other directly without communicate with any fixed infrastructure. That's why we say to that just vehicle to vehicle ad hoc network. The second category that we have in the VANET is the vehicle to infrastructure, or we say to that V2I network. And this is a network that actually all the nodes there, when we say node, it means the vehicle that we have here, they communicate with each other with the roadside. So the roadside here, it plays an important role here. And the third one is a hybrid network. So it means the combination of a vehicle to vehicle and vehicle to infrastructure. The vehicle can be connected to each other, it can communicate to each other, and also in the same time it can have the communication with the infrastructure as well. Now let's look at the VANET applications. Let I go to my comment because I see some comments. Actually, in between, I would like to say if anyone has any comments, any questions during my presentation, you can put your comment there. And at the end, definitely, I will read the comments and I will answer your question. So let's back to our webinar. Let's continue. So VANET system actually offer the number of applications, include lots of benefit at administration, driving, and convenience in vehicle as well. So most of these applications, they are proposed by vehicle manufacturer, and it can divide it into several categories. Like for example, it can divide it to the safety related application, like what? Such as intersection collision avoidance or cooperative collision avoidance, cooperative driver assistance system, and also the road hazard control notification. The other actually applications that we can mention for MANET, it's convenience application that we have, such as optimum roads with real-time traffic data and automatic parking. Let's look at the other applications that we have here, like for example, administration application that previously I mentioned. The example of that is, for example, some electronic tool collection, parking lots, parking lot payment that we have, and also traffic information. For example, commercial application is another type of the application that there is in VANET, such as internet access, digital map downloading, or real-time video relay. So generally, governments and some car manufacturers such as Toyota, BMW, and Daimler Chrysler have launched some of important projects for VANET, such as advanced driver assistance system, crash avoidance matrices partnership, and Car Talk 2000, FlatNet, and also CarNet. Okay. Now let's look at the characteristic that there is on VANET. Earlier I mentioned about some characteristic of that. I mentioned about that, how it's kind of similar to MANET, but it has different own characteristic as well. But let's look at that more in detail. As you see, I listed here for you guys. So unique characteristic of VANETs that actually distinguish them from MANET is this list that I actually put it here for you. The first thing is high mobility that they have in the actually total VANET network. So predictable and also restricted mobility pattern it has. Also, we have rapid technology change. There is no power constraint here. Why? Because we don't dealing with the mobiles. In the mobiles, in the MANETs, when we dealing with that, the power, the energy efficiency, it's very important for us. because they working with a battery. But when we are in an area of the VANETs and we're working actually on a vehicle, so vehicle, they have their own battery, so definitely there is no power constraint here. We don't consider the energy efficiency of that at all. Also, the other characteristic that the VANET has is the localization. Then we have abundant network node. We have actually hard delay, large scale network, and also energy storage and computing as well. It's another characteristic of VANETs. So you see here that the routing protocols that already exist in VANET. So a routing protocols is actually a set of rules that determines the method of connection between the node and how actually it distributes the data through all those nodes. When we talk about node, we talk about vehicles here. So the basic task of the routing protocol is actually to find the optimal path to optimal path of the communication between the nodes and to actually exchange the currency data with a low latency from one node to another, which actually all these will be specified by the protocol that these nodes they will get use of that. So that's why a routing protocol is considered as one of the most important process in VANET research that actually allows a VANET application and communication service. So it's actually defined as the protocol. The VANET protocol is defined as the process of selecting the best path between the sender, which is the source node, and the receiver, which is the destination node. Actually, this path it will be established between these two nodes, and through a set of actually VANET nodes. And in order to actually improve the vehicular safety, that's why routing should actually forward a data packet with a certain constraints. Unfortunately, the traditional routing protocol that are designed for a MANET, it faces many obstacles and they don't actually compatible with the complexity of a VANET environment constraints that already we have that, and also it doesn't compatible with the VANET requirement, especially from perspective of the mobility pattern of the node or unstable network topology, and need to actually transition data timely in warning application and collision avoidance. So these are because in VANET and MANET it's totally different with each other. Definitely most of the routing protocols that are proposed for the MANET at the first, and they use that for a MANET. First, they try that. It doesn't work out. They cannot get a good performance of that. That's why design of an efficient, reliable, and secure routing protocol according to the limitation and a unique characteristic of a VANET is the actually main challenge, which faces researchers to actually enhance the traditional protocol and implement them in the VANETs for the VANETs environment. So definitely you can understand by now that there are many aspects to actually categorize the routing protocols, such as protocols features and mechanism that it applies, network structure, routing method, routing information, transmission strategy, quality of service, and etc. So these are all the factors that based on this parameter, based on this important factor, we can categorize the existing routing protocols. So depending on a protocol's feature and depending on the mechanisms that it applies, VANET's routing protocol is divided into topology-based, position-based, geocast-based, broadcast-based, and also cluster-based routing protocol, which is my concerns, cluster-based, and at the end I will go through that. So why actually divided into these types? We have hierarchical routing, we have flout routing, and also we have position-based routing, depend on the network structure. So you see that based on each perspective, and from each perspective, definitely we have some other category that we can have our protocols here. Okay, let's look at the architecture of VANETs that we have. So VANET architecture, as you see, can be divided into three categories. The first category is cellular or VLAN. The other one is ad hoc, and the third one is a hybrid architecture. So if the infrastructure consists of cellular gateway or VLAN or WiMAX access point, the network will be actually considered as a pure cellular VLAN. When there is no infrastructure is available, so the nodes must communicate with one another without relying on infrastructure. So this denotes a pure ad hoc architecture. And sometimes various access points, such as cellular gateway, will be available actually for communication. So in this case, nodes can communicate with this infrastructure, or they may also communicate directly with one another. And this is called hybrid architecture. Okay, now let's look at actually into the VANET system architecture that we have. The communication actually between vehicle or between a vehicle and roadsides is actually achieved through the wireless medium that we call to that wave. So this kind of communication, it provides a wide range of information to drivers, to travelers, and also enables safety application to can actually enhance the road safety, and it can provide comfortable driving. So the main system component here are the application unit. As you see in the figure, we mentioned that as a AU. We have onboard unit, OBU, and we have roadside unit, RSU. Let's a little bit I talk about these are until we get familiar with this terminology actually. So onboard unit, what's onboard unit? The actually main functions of an onboard unit are reliable message transfer, wireless radio access, ad hoc and geographical routing, network congestion control, data security, and IP mobility. These are the main functions that we have on an onboard unit. So an onboard unit or OBU is a wave device that usually mounted onboard a vehicle, and it's used for actually exchanging the information with a roadside unit or with the other actually onboard units. Let's go to the application unit that we have, or AU. So the AU actually is a device that equipped within a vehicle that use the application provided by the provider, and it using the communication capability of the onboard unit. So the application unit actually can be dedicated device for a safety application, or a normal device such as personal digital assistants to can run the internet. So The application unit, it can be connected to the onboard units through the wire or wireless connection, and it may actually reside with the onboard unit on a single physical unit. The distinguish between the application unit and also onboard unit is in logic. And let's look at the third terminology, the third actually parts that we have in VANET architecture, which is roadside unit, RSU. So the roadside unit is a wave device again, which is usually fixed along the roadside, or it can be even in dedicated locations, such as, for example, at the junctions or near to the parking space. And so all these devices, we say to them roadside units. So the roadside unit actually is equipped with one network device for a dedicated short-range communication, which is based on IEEE 802.11p radio technology. And it can also be equipped with the other network devices, so as to be used for the actual purpose of the communication with the infrastructure network. Now let's look at the VANET security requirements. So definitely for applying the VANET, definitely we need some security as well. We need some requirement as a security to have. So let's look at them. Let's see what it is. The first thing that we need as requirement is the message authentication and integrity. So message must be protected from any alteration. The second requirement that we want is the message non-repudiation. So the sender of a message, it cannot actually deny to having sent a message. The third security requirement is the entity authentication. So the receiver is ensured that the sender, it can generate a message, and on the other hand, the receiver has the evidence of a liveness of a sender as well. Other security requirement that we need is access control. So actually, by the access control, we can determine the locally by policies, and also authorization. It can be established for each node that is allowed to actually be in that network and send a message. Also, the other requirement that we need is the message confidentiality, which is very important as well. So message confidentiality actually it actually shows that the content of the message should be kept secure from those nodes that they are not actually authorized to access to that. So we cannot, these are very important messaging that we should have, and definitely there are lots of vehicular application for this kind of things, in order to, it doesn't broadcast the message that is very important to everyone, that on that range of their radio access. Also, the other requirement that we need is the privacy and anonymity. So it actually means that vehicular communication, or we say that VC systems, they shouldn't disclose any personal and private information of their user, and also any observer, they shouldn't know any future action of other nodes as well. And also anonymity may not be a reasonable requirement for all entities of the vehicular communication system. The other requirement that we have is availability. So it means that protocols and also the services, they should remain operational, even in the presence of faults, malicious, or damaging. And the last requirement that we need is the liability identification. It means that the user of vehicles are liable for their actually deliberate or accidental actions that actually disrupt the operation of the other nodes. Now let's look at the actually comparison that we have between the MANET and VANET. I prepared here one simple figure for a comparison that easily we can compare the vehicular ad hoc network characteristic with the mobile ad hoc network characteristic, VANET and MANET as we see. So, as you see, as I mentioned actually before, many VANET protocols and techniques are similar to the MANET. But when we compare this type, so various characteristic and behavior is not same as much. So the main difference between VANET and MANET network is actually in a production cost. You can see the production cost as well. So the VANET production cost is costly when we compare that with the MANET. The other difference that they have is in the network topology. So the network topology of a VANET is frequent, is fast, and mobility is high because of the speed of the car. And on the other hand, MANET is sluggish and actually is slow because it's the mobile ad hoc network. You're walking and you're using your phone and you're sending the data. It's different by you are in the car and your car want to send the data to the other cars. So the topologies of that is it's changing, but it's slow. Also, from other perspective, if you want to look at them, we can look at them from perspective of the bandwidth. So the bandwidth in a MANET is more high compared to mobile ad hoc network, and the nodes actually are moving randomly in MANET, but in VANET, the nodes are moving regularly. And as you see, this figure exactly shows all the differences between the VANET and MANET here. Okay, I prepare actually some challenges that we have in VANET protocol. So networking and security, as we know, both of them, they are important challenges in VANET. So the challenge in vehicular ad hoc network are the actually communication link lifetime, which is very short and less path redundancy present here. Also, density of unpredictable node we have on the band, and also we have a strict application requirement that make the routing and network quite challenging. So vehicular ad hoc networks, they are difficult to manage due to high speed that exists between the vehicles, and it results in a topology change, fast actual topology change. So no significant power constraint, especially in sensors, the limited battery power is a challenging in VANET as well. So the networking challenge in VANET is the main area of work for routing security and actually efficiency and also collision avoidance. That's why actually intelligent transportation system face many challenges in application, routing, power management, and etc. So there are many challenges in application of communication for collision warning, for road obstacle, or cooperative driving, intersection collision warning, lane change assistant, and etc. The important task of the VANET actually is providing data communication in vehicular area that they're using wireless transmission to avoid actually accident by sending the data of the vehicle's speed and position to the another over a network. So to actually achieve this goal, we need to design a routing protocol considering factors such as security, mobility, and also scalability of the vehicular network. So as you see, there are many routing protocols in the ad hoc network environment, but in VANET, routing is difficult task to achieve because of its high mobility, because of low latency, high growth in size of the network, privacy, and also the security requirement that we have it for VANET. That's why it's a very challenging area. Generally, researchers began to pay attention to VANET after I think 1980s that have now been an active scope of the research and the development. So many kind of challenges in vehicular communication actually have been specified and addressed already. So a large number of routing protocols that have been proposed for MANETs, it doesn't suitable the constraint and requirement of VANET environment. And also a routing protocol domains, the method that two connection that entities exchange the information. It includes the procedure for actually establishing a route, decision in forwarding the packet, and action in maintaining the route or recovering from the routing failure. Okay, now is the time to actually talk about Internet of Vehicle. But before that, let I go to our comments. Let's see if anyone have question so far. Okay, I think up to here is clear. Karzan asked what's the topic is. So the topic is about the architecture and the protocols that exist in MANET, VANET, and IOV, and also all the challenges that we have here. Okay, so let's move on and look at the IOV more closely and all the details about that. So in recent years, number of sensors-enabled technological device like vehicles on road, smartphones in pocket, laptops, tablet in office, or TVs and music system in house. These actually sensors-enabled technology devices, all of these have significantly increased in our daily life. You see that we use that. And the universal network framework for these devices constitute the basis of a future Internet of Things, which is IoT, and we talked about that, to which actually 25 billion things will be connected together in one day, among the significant portion that will consist of on-road vehicles. So we'll see that actually this growth will create a challenging but profitable market for the future connected vehicles. So as more vehicles are connected to the IoT, conventional vehicular networks are mobilized into the Internet of Vehicle or IoV. So as you see, this figure illustrates IoT opportunities for a next generation of information and communication technology, that we say to that ICT area. So the IoV actually represents the evolution of vehicular ad hoc network for providing a smart transportation. The sole aim of conventional VANET is actually to enhance the traffic safety and efficiency by using real-time communication that actually connects every vehicle into the wireless router or mobile node. And in turn, it can create a large network. Consequently, if the vehicles they move out of the VANET signals range or drop out of the network, other vehicles can join by creating a new network. However, the actually commercialization interests of VANET have not been developed sufficiently. And despite their huge potential for vehicular safety with a low operational cost. So VANETs actually have also limitation in connecting number of vehicles and mobility support because they cover very small area and definitely they cannot provide the global positioning service for the desired application. So with the safety being the prime goal, the continuous modernization of the vehicles and road infrastructure, growing traffic casualties in recent years, and it has become actually serious concern. That's why, or as I can say, therefore, reliable, actually cooperative vehicular communication can introduce a new era in road safety by actually reducing the traffic casualties. And generally, the focuses of IoV is to intelligently integrate the vehicles, things, humans, and the environment, and also they create a larger network which can provide services for larger cities. Also, these services can be further extended up to the whole country as well. Okay, now I would like to actually talk about the different type of the networks that we have in the IoV. So, as I mentioned before, the IoV is an integral part of the IoT, which actually connect various heterogeneous networks. For example, inter and intra-vehicle network with the internet. So, this heterogeneous network architecture, it can be categorized into 5 types of the vehicular communication. We have, for example, VANET. VANET, it had 3 types of the communication, but in the IoV we have 5 types of the communication. We have vehicle to vehicle, V2V. We have vehicle to infrastructure, V2I. We have vehicle to roadside, V2R. Up to now is same as that, but the other 2 is just dedicated for IoV network, which is vehicle to sensor, V2S, and also vehicle to pedestrian, which is V2P, and as it shows in this figure as well. So it's anticipated that enhanced traffic safety, improved traffic efficiency, and implementation of supervision and control can be assured by IoV. Like, for example, information exchange through the inter-vehicle communication and also real-time broadcasting of the traffic condition to the data center. So its purpose actually is to ensure that devices can communicate with each other and they can exchange the information with intelligence. Moreover, the research and development of IoV technology will integrate automotive and information technologies together. Now I would like to actually talk about the heterogeneous network structure that we have in IoV. So the communication architecture of VANET, you saw that it can be divided into three categories. So this category is gonna be this category of the communication architecture is gonna be same for IoV as well. So what we have here, earlier I mentioned, again I will mention as well, we have wireless access vehicular environment, which we call to that wave, and it's based on Wi-Fi. And on the other hand, we have ad hoc architecture, we have hybrid architecture as well. So each vehicular communication of IoV is actually enabled using a different VAT. It means different wireless access technology. So the VAT actually it includes IEEE wave for a V2V and also for a V2R. We have Wi-Fi technology and 4G or LTE technology as well, and we use that just for V2I communication, CarPlay, and for a V2P communication. And also, in the other hand, we have MOS and Wi-Fi, which just that technology is going to be used for communication between the vehicular and sensor network. So as you see in this figure, everything with the range and with the exact VAT, which is wireless access technology for each different category of the communication that we have, it is specified. Now let's look at the IOV'S architecture. So the architecture of IoV, as you see here, it divided into 4 layers environment. 4 layers. The first layer is the environment sensing, as you see in the low level. It is, and then we have control layer, we have application layer, network access, we have transport layer, and we have coordinative computing control layer. Let's from the low level we look at this level, and I explain it. You can look at the figures and you can catch my explanation as well. So the low level that we have is the environment sensing and control layer. So for the implementation of IoV service, vehicles, control and traffic environments play a vital role actually. So sensing is actually performed from both vehicles and environments perspective. Vehicle sense and it gathers the information from the surrounding to actually avoid mishaps. And along with it, this layer also it gathers the dynamic information of the environments, humans, and also the vehicles through the sensing technology, as well as it relies on some methods to implement the SWART sensing. Now let's look at the other level, that the second level that actually we have here, which is a network access and transport layer. Node management, data processing, remote monitoring, and also data analysis are the main task of this layer within IoV. It also takes into consideration network load constraints and heterogeneous network access for all the vehicles within an IoV network. On the top layer of that, which is the third layer, we have actually coordinative computing layer. So this layer actually is concerned about coordination in the IoV environment, either by supporting the interacting of a cognitive computing capability, or even SWAR intelligent cooperative computing capability. So data processing and and also resource allocation are also provided by coordinated computing layer, by this layer. In the fourth layer, as you see, we have application layer. So in the application layer, we have two types of service which are offered by the application layer for IoV actually. As you see here, we have closed services and open services. Real-time traffic services actually offered by numerous internet service providers, which it falls in the category of the open service and should support the business model. On the other hand, we have closed services. And this type of the services, they focuses on a specific application like control platform and traffic comments. And this layer also offers open services capability to the third-party providers. Okay. Now, let's look at the category of application that it's supported by VANET and also by the IOV. So this figure actually specifically, it shows the category of the applications that is supported by IOV and VANET. A massive and tremendous amount of services and applications are being supported by VANET and IOV, and it can actually impart the voluminous and crucial information to the on-road drivers and also to the travelers. So application of the IOV, it can be actually divided in following broad categories. Like what? Like safety related application. Or the other category we can have as a comfort and information, or traffic efficiency and management. Also, we can have the other category as a healthcare application. So each of these application types, they can be further categorized into the other numerous application as well. Now let's look at the wireless technology of IoV, or VAT, as I earlier mentioned about that a little bit in the context of IoV and their communication base. But now we want to look at it from other perspective. So as a result of IoV's heterogeneous network environments, client application would have actually access to the range of VAT to initiate connection with a server based on a smart cloud. And there are actually three categories to which the VAT can be divided into: cellular mobile, a small range static communication, and also actually that are dependent to the network communication, which utilize different VAT as well. So there are actually three distinct type of the communication network to which this technology were deployed for. So there are differences in their features, that is to say weaknesses and strengths that they have. So these differences are actually, as you see, listed in this table that I wrote here, based on 6 important factors that each has a different priority for utilizing the wireless technology. So in VAT, the 6 significant parameters included here are the mobility support, communication range, data rate, communication delay, scalability, and also the security support. So actually, in order to select the VAT for a specific client application, It uses the wireless technology prioritized preferences. And so to successfully actually can maintain the quality service of them, appropriately selecting the topology, that will be very helpful. Okay, here in this figure, I brought you the different routing protocols in IOV that we have. So despite the fact that there have been many routing protocols which have been published, there has not been not much actually that focuses on a heterogeneous model when we look at the actually network targets perspective. So rather than what the researchers they did, they actually concentrate mostly on a homogeneous network model, which has opened up diverse challenge that has to be addressed. So the challenge being referred to here, it includes the gateway node in network, handoff timing, the best wireless technology to can transmit the packets, vehicles mobility behavior, and also IP addressing. These are the main challenges that we have. But as you see here, we categorize our routing protocols based on their transmission strategy, based on their delay based on the information that is required for them, as earlier I mentioned. Now let's look at the routing problems that we have. So also I mentioned about that, but it doesn't matter. So the first routing problems that we might have is the timing of handoff. And the second one is the gateway node in VANET. So the first two approach actually that I named now, they treat the routing as a problem of making decision about which technology and connection we'll use. While the third challenge that we have, which is the wireless technology, which wireless technology actually we should use for transmitting our packet. The third one, it actually make the choice for every packet and even in the process of a forwarding packet. And therefore, decision making definitely should be done according to the packet forwarding, and it should be done based on that which radio technology and connection should be chosen. So these are the challenging issues that we have actually. Now, let's a little bit more talk about IOV. The main reason that IOV is more complicated than VANETs. I want to bring those kind of reasons now. So actually, the main reason that why IOV is more complicated than VANET is that IOV often includes different radio technologies, whereby it leading to the heterogeneous network. So communication in vehicles is actually possible through onboard unit that earlier we talked about that. This onboard unit installed on the vehicle over a dedicated short-range communication or DSRC. And this dedicated short range that I'm talking about, it worked in 5.9 gigahertz band with a bandwidth of 75 megahertz. And approximately the maximum range that DSRC can cover, the maximum of that is 1,000 meters or 1 kilometer. And the lowest one is 100 meters. So VANETs actually follows some standards, the IEEE standard of 802.11p standard, which is assigned to the wireless ad hoc vehicular environment or the way. So VANET insists cooperative communication with peer node in an operation environment of a high mobility and also dynamically changing their topology. So these challenges can be addressed by class-served network Um, and also clustering is a technique to group the nodes. And each cluster, they have their own cluster members or cluster nodes that we say to that CM or CN, and they have cluster head that we say to that CH. So the cluster head actually is a leading node of a cluster, and it's responsible for actually coordinating all the cluster member in the cluster. And the major challenge for clustering algorithm is to actually ensure stability in a highly dynamic environment. And the efficient clustering algorithm, it should actually focus on forming the minimal number of the cluster, and also to can maintain the current cluster structure and keep the overhead at the minimum level. So most of the existing VANET clustering algorithms are derived from the MANET, as I mentioned before, from the MANET clustering scheme. And these algorithms, they don't actually consider the mobility characteristic of a MANET. That's why for efficient clustering, a stable clustering is required. Therefore, the actually main goal is to enhance the cluster stability, where the vehicles it change their speed and their direction as well normally. Now let's look at the clustering technique more in detail. So there are actually several advantages of routing protocols, which are cluster-based over the routing protocol without any hierarchy. So these advantages are higher scalability, it's higher throughput, lower overhead, and better system capacity. Better system capacity usage actually, due to the better performance in the back layer. Other advantages, routing table size is reduced actually with the clustering at the network layer, and it can decrease the transmission overhead, which is as an actual result of the updating routing table and changes in the topology. So actually, a more stable and scalable communication schemes can be created by clustering techniques. And as I earlier mentioned, clustering techniques is for assembling a group of a node. Like what? Which nodes? Like mobile gadgets, devices, automobiles, and etc. inside the geographical locality, according to the certain regulation, certain rules. So such a regulation, it varies from one algorithm to another, and therefore are the actually decisive aspect in creating the dependable clusters. So clusters are virtual sets that are created by using the clustering algorithms, and each cluster actually is composed of, as I said, cluster node or cluster member that which actually nominated or elected a single CH for that specific cluster. So the group of nodes within a CH transmission range, it referred to as its neighborhood. And in most cases, any cluster node can be elected as a CH. However, in several algorithms, some type of nodes poses more actually effective property for becoming the CH. For instance, a CM, for example, with supplemental 5G network connection is often definitely more desirable than the non-5G person. And the other thing that I should mention here is the cluster size, which cluster size, it depends on the node's transmission. transmission range. And as a result, actually, it varies from the cluster to cluster. And generally, clustering implies separating the network actually into the smaller logical groups, which actually can increase the lifetime of a network. Okay. Let's now look at some literature review, the previous works that it done in the context of the IOV, MANET, and VANET. So as you see here, several principal technology and techniques, actually, several principal techniques, they are proposed by researchers for actually optimizing the network efficiency by using the tradition and also by using the hybrid clustering. Here, I should actually talk about at first multi-objective optimization problems, or MOPS. So, multi-objective optimization problems arising from real-world applications that have attracted actually great effort from AI, artificial intelligence, community. So, since those objective functions in MOPS, they may conflict with each other. Therefore, researchers usually seek for a set of trade-off solutions. Like what? Like, for example, Pareto optimal solution sets. Rather than, for example, unique solution. So, since these evolutionary algorithms, they are capable of handling a set of solutions for complex problems. That's why many multi-objectives evolutionary algorithms, they have been proposed for MOPS in the recent years. And in multi-objective optimization problems, actually evolutionary algorithms are a reliable way of obtaining the multiple solution, which is very important. And these algorithms are designed actually to get several solutions at the time, rather than they just gain a single solution. So many evolutionary algorithms, they have been actually deployed to work with different mechanisms. For instance, the genetic algorithms, differential evolution, artificial immune system, and swarm intelligence. So some SI or swarm intelligence technique which are proposed, I mentioned in this table, these are just some of them. So there are a lot as well. I just categorized these parts. And as I mentioned earlier, one of the multi-objective optimization technique is a swarm intelligence, which is an evolutionary technique that is actually inspired by the natural world. And it has been used to solve various difficult optimization problems. So SI contains various widely familiar algorithms, such as ant colony algorithms, ACO. So the fundamental theme of ACO is actually extracted from the daily routine of ants. Now let's look at the other category of the MOPS. So as you see, we have physical-based algorithms. So in the physical-based, the physical principles of nature are followed to actually can optimize the research problems. And the variation of this method from other is that it follows the physical rule, the rule of nature. So some of the physics-based optimization algorithm, as you see, are shown to you in the table too. Also, on the other hand, we have other category, which is the evolutionary algorithms. And in this method, actually, the theme of evolution of nature is used to solve the problems So genetic algorithm, is one of the well-known by inspired algorithm in which process of actually mutation and crossover which is used there. And some of the evolutionary algorithms, they are described in the table 3 as you see. Now let's more look at in detail about the optimization problem in IOV that we have. So actually, to solve the routing problem in IOV, multi-objective optimization, it can be used as I mentioned earlier. So MLPs are problems that are actually based on multiple constraints, and they have more than a single solution. Evolutionary algorithms are preferable for MLPSs as they are actually population-based and enable them to actually produce multiple solutions in a single iteration. So as you see in this equation, we have, for example, W1, W2 up to Wn. What's this W's? Wi, let I say, they are represent the weights. The weight that actually they assign to the i's objective function in the range of 0 to 1. And it denotes the decision variable here for the multi-objective problems. So, for instance, we can have different decision variables. And for example, some decision variable that I can mention for clustering in IOV is, for example, the distance of a neighboring nodes from CH. So if that distance, if be less, definitely is more ideal. The other decision variable that I can mention is actually movement speed of the CH. So if the movement of our CH or cluster head that I said is similar to the movement of the other node in that cluster, definitely is more ideal. And as a third, for example, a decision variable for IOV, I can mention about the direction of a CH in a cluster. So definitely we prefer that all the nodes in a cluster, they go in one direction, not one go back, one go to the other direction. Also, we can consider, for example, the velocity and other decision making as well, based on that, which actually protocol we want to propose or we want to modify, and what's the important factor for that particular network. So we can think about different objective functions, and we can put that on that formula, and we can simulate our simulation, and we get the results based on the parameters that we give to that. Now, let's look at the research challenge as I promised, and this is actually the last slides that I have. Do not worry, I don't want to go longer than that. So we have some research challenge in IOV. So the implementation of IOV is still considered as a challenging issue. And also few research challenges are discussed here, and based on my survey, I actually include them here. So as you see what we have as a challenge, we have, for example, localization accuracy. We have localization privacy or localization verification. These are challenges that researchers still they can work on it. Or for example, lack of a standard to enable the robust V2V communication that many researchers definitely they working on this area as well. Even me by myself, I'm working on this area. Or for example, enhancing communication ability, or network model and service model of the human vehicle as well. So these are all the open challenges that we have, and we can consider that for further researches. So let's go to the conclusion, and I don't take your time much actually. So in the last year, increased interest toward research on different issues in VANETs. And also IOV due to increased technological growth in the wireless communication technology and also vehicular companies that we have. So the routing process, actually, as you saw, is one of the main challenges in both VANET and IOV. IOV, as you saw, it becomes the key enabling technology to actually realize future autonomous driving scenarios. And IOV is an integrated system that interconnect people with around vehicles, intelligence system onboard vehicle, and it connected to the various cyber physical system in urban environments. So it has actually gained a huge commercial interest and research value due to rapid development of computational and communicational technology like edge computing, grid computing, parallel processing, big data analysis, web semantic, and artificial intelligence. So based on our actually finding and surveys, it's analyzed that although Internet of Vehicle has a great potential in research transportation system, still there are numerous issues which need to be taken into account, into consideration. And it has applications in different areas, like safety related, traffic safety, comfort and infotainment, and also healthcare. But it's actually required to enhance its applicability in order in other area too. So along with this, actually existing proposed security solutions have a number of flaws which need to be addressed, actually further. And we have some security problems as well that these all need to be addressed. And many researchers, they work on finding different solution for a security issue that exists on VANET and also IOV. So as you see, let I have a quick recap. In this webinar, as you saw, I described different type of the routing protocols, characteristic, architecture, and issues for a MANET, VANET, and also IOV. Moreover, you saw that in the field of intelligent transportation, IOV, it plays a very vital role, and it's the most prior application of Internet of Things. So this technology has great potential in the prospect of research and also commercial value. And it can be actually regarded as a backbone in the development of a new intelligent transportation system. So thank you everyone for attending to my webinar. I will check my comments if there is any question and I answer them. Okay, so far so good. There is no question I see here in the comments. If anyone have questions, definitely, I think one link, it went there to show you exactly, you can put your questions or your comments if you have there, and you can chat with us with that link to let us know how this webinar was helped you or not. So thank you for your time, everyone, and have a good evening. Thank you. Bye.